think I'm good to go now. So I'm going to apologize in advance. This is definitely going to be a rough talk. I'm a little unprepared, but I have some demos to show. And the main thing I want to show here is that as a person who's been a developer for a while and really never touched the hardware stuff at all, this was, getting into the hardware world with Arduinos and components and electronics engineering and all that stuff was really daunting to me because I knew absolutely nothing. I still know very little. What's awesome is that thanks to JavaScript and Node and some awesome libraries that have been built on top of that, it's made it incredibly easy for me to get into this stuff. And I feel like I'm cheating because it's so easy and I still know so very little about just electricity in general even. But that's okay. It's cool to have these tools available that let me accomplish things and see results and have fun with it. And I'm still learning along the way. So it works out nicely. I would feel better if I had a little bit of a deeper knowledge of electronics in general, but I'll get there. So again, this is all thanks to Node. And then on top of Node there is a library called Node Serial Port, which is developed by this guy, Chris, and I want to give his last name because he's awesome. Voodoo Tiki God is his handle online, which is great. I saw this guy give a talk on Johnny 5, and this is what really just sparked me to get into this down at a conference in Oklahoma City called Thunder Plains. It's a big web development conference they have down there every year. Definitely check it out. We try to go every year, and it's always a good time. Chris Williams. So this guy is awesome. He built this library called Node Serial Port, which allows a running Node process on a computer to communicate over serial port with an Arduino or a BeagleBone or a Raspberry Pi or something along those lines. In this case, what I'm using here for tonight's presentation is a SparkFun Red board. So it's an Arduino. It's really, really similar to the Uno. There's some minor differences, and if you look up differences between Redboard and Uno on Google, it'll have a thing on there that lists them really nice and clean. But they're pretty similar, so it's just about the equivalent. So how I got into this was I ordered the SparkFun Inventors Kit from SparkFun. It's $100. It came with a Redboard, a breadboard, a whole bunch of jumper cables, and then some random components to get up and running with, and then a little book showing how to wire them. It also came with a whole bunch of C code examples to run all these different components. But of course, naturally, I didn't touch any of the C at all. I loaded the standard Fermata on my Arduino, and then immediately jumped in and started working with Johnny 5. So Johnny 5 is a library that's built on top of Node Serial Port that contains all these common components that you can work with. So the documentation for Johnny 5 is fantastic. And actually this website here just launched, I think within the last week or so. I know it's pretty new. So I haven't actually had a chance to look through everything on this website. But even when all the documentation was just here on their GitHub page, it's been fantastic and incredibly easy to work with. They even have picture diagrams that show how to wire certain components. So great reference. And they also have a lot of examples on here of really cool things that people have done. So if you scroll down a bit, so this is all the different components that it supports. So it shows how to just connect to the Arduino itself. That's what the board is. So you have all these different types of LEDs that you can hook up, different types of servos, motors, stepper motors, sonars, buttons, of course. So it goes on and on. So you can see there's a lot of stuff that's already just pre-packaged for you, which gives you an API specific to each one of these types of components. So that's awesome. Even remotes. So very, very, very cool. And then if you scroll down a little bit further, you have these really cool examples of things that people have done with Johnny 5. So people have built some really complex and cool things out of this. So even though I say it feels like cheating, and you can't actually load the JavaScript code itself onto the Arduino, you have to have some kind of machine connected to it, communicating over serial port. So you know, having my laptop connected all the time is kind of impractical. But if I were to actually, you know, build something and put it out there, I would probably use a Raspberry Pi and have Node running on the Raspberry Pi and then communicating with the Arduino from there. So much smaller form factor. But for now, I just carry around my laptop and the Arduino in my other hand. So let's see here. So I guess let's get started. So the easiest way to get started here, the first example I'm going to show you guys is how to work with an LED. That's kind of the flagship first thing that you do with, I think, electronics in general, but definitely with Arduino, is hook up an LED. So I already have this installed here, but normally, assuming you have Node installed on the system already, I don't want to go through all of that. It is pretty easy to get set up, though. We do npm install. npm is Node Package Manager. Doesn't stand for that, long story. And then we say Johnny-give 5. There we go. So, and I already have this installed, but it's going to go through and try to do it anyways. We'll pretend this is my first time. And you can see there it's installing the serial port module, building some other stuff, and there we go. So now that I have that up and running, what I'm going to do is say var 5 equals require Johnny 5. So this variable now contains all of the different components that I might want to work with. So the next thing I'm going to do is create my board. So this is going to be the variable or the object that represents my Arduino, the board itself. And we're going to say new 5.board. So if you're familiar with JavaScript, and especially Node, it's very event-driven. It's asynchronous, and doing things based on certain events happen. Can everybody see that okay?
Like 6 point lines.
Yeah, that's okay. Yep. I'll even do this. How's that? Cool. Okay, so everything in JavaScript generally is asynchronous, so it's very event-driven, and this is no exception. So what we're going to do is we're going to say board.onReady, and we'll just say the board is ready. So let's start with that. We'll come over here, and we just run these with Node and then your file name. So my file name over here, if you guys didn't see, is working.js. So as a backup, I have all the examples I'm going to show tonight pre-written just in case I stumble at all. But I like to live code, so we'll see if I can get through it that way. So Node, working.js. So you can see I already have my board plugged in here over USB. And so that it found the device at dev/cu.usb serial and then the ID for it. And then we see our message, the board is ready. So it tells us it did connect to the board. So that's cool, but we don't really, it doesn't do a whole lot for us. So let's, I've already got an LED plugged in here. One thing I didn't want to spend a whole lot of time on is how to wire these components. I wanted to keep the purpose of this talk focused on just how to work with the components through JavaScript. Again, the kit that I got here to get started was the SparkFun Inventors Kit. I've gotten some of the components I'm showing tonight I bought after that fact, but it comes with a great book that shows how to wire these all together. And again, there's examples on the Johnny 5 website too. So if you want to check that out, those are great places to figure that stuff out. Or you can come up here after the talk and we can mess with this stuff some more. So I have my LED already wired onto my board here. So I'm going to say var LED equals new 5.LED. So in this case, I have to tell it specifically what pin on my Arduino this LED is connected to. And in this case, I have my LED on pin 13. So what I'm going to do is in here, in new 5.LED, I'm going to pass the parameter 13 so it knows that's where the component is connected to. Yes? Good? Good. Cool. If you guys have any trouble seeing it all, just let me know. I'll gladly bump it up some more. Okay, So we're saying we have this LED, it's on pin 13, and maybe we want to do something with it. So at this point, I have access to it, but if I start my board, if I restart this, as it's booting up, I see my LED blink a couple times, but it's just off. So I've made my LED, but I'm still not doing anything with it. So one thing to note here is that I have this message, and I realize that's up a little high there. There we go. So whenever I run this, I get this message after connected that says REPL initialized. And for those who aren't familiar with what a REPL is, it stands for read, evaluate, print, loop, I believe. So it's basically an interactive shell where I can type in JavaScript commands and it will just execute them immediately, and then I get to see the result of that. So that should be a hint that maybe I can, work with the components on this board directly from the REPL on my computer. So let's do that. And the way that we do that, the REPL is attached to the board itself. So we get to the REPL through board.REPL. And the REPL object has this method called inject, where we get to inject certain objects into the REPL environment. So we're going to inject the LED in there. So we're saying in the REPL, I will reference it by the name LED, and then we give it whatever object it refers to, which in this case is the LED variable that I created a couple lines up. So now if I start this over, REPL initialized, and let's just see what LED shows us. So there's the LED object. There's a lot of stuff here. I haven't dug into everything that this does, but clearly there's a lot of different things that you can manipulate on a pretty granular level here, which is awesome. But that's all fine and dandy, but what's great about Johnny 5 is that it makes it super easy. I don't have to understand what any of this stuff means to be able to work with this LED. So let's just guess here. This LED object has methods that we can use to control the LED. So what would be the most logical way to turn this LED on? LED dot on. Let's try it. It seems to make sense, right? And yeah, I realize for the live viewers, you can't see the hardware I'm working with here, but a lot of the examples I'm going to show here in a bit will be showing things that show up on a web page. So just connecting between the web page.
Poke the LED that you're talking about.
This one right here.
Okay.
So it's this one, this little green one sticking up out of the board. So let's see here. Boom. Woo! All right. Yeah, I didn't expect too much applause for that. So, and then naturally, LED.off turns it off. What else can we do? Maybe LED.blink. So we say we want it to blink, and we give it 100 milliseconds. So it's going to turn on and off every 100 milliseconds. So now we have a blinking LED. Now maybe I want to turn it off. Well, that didn't work. Stop. There we go. Now I need to turn it off. Okay. So that's pretty cool. We can inject components directly into a command line, start working with them through JavaScript. So that's awesome. And again, all of this is made possible by Node Serial Port. So I would be able to do these same things with just Node Serial Port and not Johnny 5. But Johnny 5 is what gives me these predefined components that have all these convenience methods like on and off and blink, and other ones that we'll see for other components we're going to work with. So that's pretty cool. So the next thing I want to show you is a button component. So if you look on the board again, I've got this green button here. It has a nice satisfying click. And we want to make the button turn on the LED. So if I look at my button here, I have this connected to pin 2 on my Arduino. So we're going to say var button equals new 5.button, nice and obvious, and pin 2. So a button isn't something we necessarily send commands to. An LED is something we would send commands to because it's something that we can actually control. An LED is not something we send commands to. It's something that sends commands to us. the button is going to tell us whenever it gets pressed so that we can do something in response to that. So again, a button press is an event. So naturally, JavaScript fits this perfectly. So we can say button.onPress. Let's start with this. We'll just say console.log, the button was pressed. In my debugging, I like to use all caps just to make it super obvious. So let's run this again. And we still got our LED hooked up. The button was not pressed. That's okay. Maybe it has an initial event that fires on that. But we press it. Every time we press it, we get the button was pressed. Hopefully that click is loud enough that the people viewing the live stream can know that I'm actually pressing the button and not cheating. So pretty cool. But again, we want to turn the LED on whenever the button gets pressed. And I'm sure you guys have all figured out how to do that by now. So let's say on. So let's run that again. And I'll hold this up again. And okay, so the LED was already on. That button event fired initially, so that's probably what turned it on. But notice I'm pressing it and it's not turning it off. So that's not very useful. So does anybody have a guess on what convenience method might be available that would handle this instead of having to detect whether it's on or off?
Oh.
Let's find out. I'm telling you, this is what I love about Johnny 5. Everything is super obvious. So we got our LED, it's on, press it, it turns off, press it again, it turns back on. So awesome. You know, I was worried at first about, you know, live coding because sometimes that can take some time, but this stuff is just so simple and easy and succinct that, I mean, I'm probably going to have trouble filling my time, even live coding the entire thing, which is why I'm talking to fill time right now. So let's find out. So we'll just look at LED and just looking for anything here that might hint that that's possible. In all honesty, I've never, I haven't tried to do that before. I imagine it's possible, but we will find out.
We'll try to help you feel some time.
Thank you. I appreciate that.
Is variables up there somewhere.
Yeah, is connected and is ready. Yes. Yeah. Debug. Debug true. Maybe we can search for state. Nothing. On. There. So I know that we have access to all of these pins here. So if you look, I've got access to each one of these pins. So I imagine if I dug into the pin itself, you know, it might also help just to look at the documentation.
Well, the state definitely has to be there, otherwise toggle couldn't do.
Right, exactly.
So the state is in there somewhere.
And I know, that's why I say, I know if we dig into the pin itself, I imagine we can see if it's getting a charge or not. But I would imagine.
I saw a high and low. Those are constants.
Yeah, that's, yeah. Just because it's on a, make sure I don't lie to you. Never mind. I was about to say something that was going to be completely wrong. So I'll just stop right there. But yeah, so here's the documentation for the LED component. So we can scroll through here. And again, see, it gives us these great diagrams to show how to actually hook these things up, which is awesome. I guess just stop, off, and on. And blink and toggle. Well, that's okay.
That'll be my homework.
There you go. There you go. You'll have to report back in the node channel. Yeah, that's a, yeah. I'm positive we could figure it out if we dug into the pins, but do what now? Yeah, right. Cool. So we've seen how to work with a button and to work with an LED. So a button is kind of a type of sensor. It will feed information to us, which in this case is just when it gets pressed. And the LED is a component that we can control, which in the simplest form is just turning it off or turning it on. But I'm a developer, you know, that I'm a web developer specifically, so I liked the idea of being able to connect web interfaces or any kind of application, mobile, desktop, whatever, with some kind of hardware. So the next thing that I immediately dug into was, how can I connect this to a web interface? I want to turn this LED on and off from a button on a web page. So that's what we're going to do next. I'm going to pull up an example here. This is a little bit more, there's a little bit more stuff going on here. So I'm going to pull in the HTTP library. I'll just copy these over. So I've got 3 node libraries I'm pulling in here. HTTP is part of Node Core. It's just the part of Node Core that deals with creating HTTP servers or doing anything over HTTP. Express is a micro framework, so that's just going to give us a really quick and easy way to define some routes. IO is from Socket IO, so that's a WebSocket framework. That's what we're going to use to actually communicate over WebSockets between the client side of the website and the server that's going to be running in the background. And then we've already got our board, so we're going to create our app. So this is our Express web server. We'll set our port to 3005. So again, this is all going to be running locally on my machine. And then we want to tell it we're going to use this public directory. So this just tells it where to serve static files from. So I've got an HTML file already made in a public folder here. We have some things I was working on last night that I didn't get working. Let's delete those. So we can do things kind of in, there's a couple different orders that we could do things in here. I chose to listen for the board ready event first, and then launch my web server. So that's what we're going to do here. We'll just come down here a little bit. So I'm creating my server using the HTTP module, calling create server and giving it my Express app. And then I tell it to listen on, I tell it to listen on the port that I defined up above. And then whenever that's actually going, we just log to say we're listening on that port. So the next thing we want to do is tell Socket IO to listen for WebSocket connections through that particular web server. And then we have some more event-driven stuff here. We say whenever our IO, which is our socket connection, gets a connection, we want to just log to the console to say we got the connection. And then at that point, the IO connection returns a socket in the callback here. So this is listening for events on over that WebSocket from that particular client. So I don't want to dig too far into WebSocket specifically here because that could go for a long time. But basically we're saying anytime we have a client connected over WebSockets, and that socket connection sends us a press event, we want to call led.toggle. So just to show you guys really quickly, HTML here. So I've got just a really bare HTML page. I have a button that says do something cool. Hopefully it does. I'm pulling in the client side of Socket IO. So this is the part of the Socket IO library that is intended to run in the front end of a web page. And then I have, what is it, 1, 2, 3, 6 lines of JavaScript, 5 lines of JavaScript if you don't count the blank one. So I'm creating my socket. And this is just going to automatically try to connect on localhost, which in this case we are running localhost, so that works. And then we grab a reference to our button, we say we add an event listener to the button that says anytime the button is clicked, we want to emit a press event over our socket. So this will send the press event to the server. And just again here, this is where we're listening for the press event and running something in response to that. So it's pretty simple. I mean, this is a very small amount of code to achieve something pretty cool, in my opinion, at least. Maybe you guys are hard to impress, I don't know. So we will launch this. Again, it connected to the board first. Once the board was ready, then it launched the web server. It tells us it's listening on port 3005. I already have the page up, so it's listening, except this is the wrong one. And here's our page. I'll zoom in really big. And so we're going to press this. It's on already. I'll hold it up again and press the button, and there it goes. So now I'm controlling an LED from a web page. So if I were to expose this particular web server, to the public or to, over the internet and put in some kind of authentication system so that not just anybody could do it, then I could, deploy a web app that has this button and control a light from my phone. It would be that easy. So it's pretty cool. Go ahead.
Just this last week, I was actually working on something extremely similar. I have a Raspberry Pi that I have hooked up to some actual relays so I can control actual AC current. So I have it set up, I can turn my lights in my bedroom now off and on with the web page. And then I also put in a physical button as well.
Nice. That's awesome. And so again, this stuff is all completely new to me. And I intended to demo a relay tonight. And I got as far as having the relay working, but never got around to getting a cheap lamp from Walmart that I could tear the wires apart on and plug it into the relay. I have the relay here, so if anybody wants to donate a piece of something that we can hook up to it tonight, we can definitely do that after the presentation. I would love to. Do what now? We could. I mean, maybe. So yeah, but again, it's really cool. Did you use JavaScript to do that, or was this?
I used Node.js.
Awesome.
And just some GPIO libraries
Nice.
for Raspberry Pi specifically. I didn't know about this Johnny 5.
Yeah. Again, Johnny 5 makes it way too easy. So, but again, pretty cool stuff. Press the button, LED turns on and off. And this button here still works. We didn't take out that code, so I can still use the physical button. So, very cool. All right, how am I doing on time? Awesome. I didn't mind too much at the presentation. It didn't end up being really long because I figured this is the kind of thing that we can get everybody to crowd around and we can mess with it some more afterwards. So you guys definitely feel free to stick around and mess with this with me after. Okay, what was my next one? Range. Okay, so this is a component that didn't actually come with the Inventor's Kit that I got from SparkFun. This thing actually, it costs a little bit more than I would have liked, but it was about $25, but it's an ultrasonic rangefinder, and it gets a range of up to 100 inches, I think. So it's got a pretty good range on it, and it's been pretty accurate as far as I could tell. When it only gets inaccurate when you get too close. So once you get within like the, anything up to like 5 or 6 inches, it can start kind of jumping around a little bit. And I don't know exactly why that is, but I assume it has something to do with the sound bouncing a little too soon. But again, I've been very pleased with how well it's worked, and it's something I used on a project that I demoed at the recent Make ICT open house as well. So it was a lot of fun.
So basically, if you have time left over, you're going to walk through a missile guidance system. Ajax Auto.
We can try. We can certainly try. I don't know if Johnny 5 has support for that component yet, but but we can look, and maybe we can submit that. That'd be great. Let's see here. Yeah, okay. So I'm just going to keep working in the same code here. Let's get rid of our button and our LED. that we don't have too much code clutter here. Okay, so all I have right now is my base for my Johnny 5 board and my Express server and WebSockets. So one of the components that Johnny 5 has listed in here, is Sonar / ultrasonic. So if I look at the Sonar component here, it shows me a little example. I create a Sonar object. It's new 5.sonar, give it the pin. I have mine connected to pin A0. And then it shows some of the different things that we get. So we can get sonar.voltage, just to get a raw voltage reading. We can get sonar.inches, so it'll automatically convert that voltage into how many inches that's equivalent to. We also have centimeters. And then we have two events that we can work with. We have data and we have change. I think, yeah, just change. So data is fired continuously. So just, I don't know what the actual rate that it's fired at is, but it's pretty frequent. And that's just going to give a real-time reading of whatever data it's returning. Change is only going to fire if that distance reading actually changes. So if we've got something that's moving in front of it, change is going to fire frequently. If we have a completely still room, the change event will fire only when there's an actual change in the range. So yeah, that's pretty much all there is to it. Again, super simple. Here's their awesome diagram to show actually how to connect that. I followed this to get all this working. I had absolutely no problems. So, all right, so let's say var sonar equals, actually let's call this range 5.sonar on A0. So there's our rangefinder. When we have a connection, we're gonna say range.onData. And actually, we'll use change just to be a little bit more efficient. And in this case, so the way WebSockets works is that it's two-way. It's two-way communication, real time. So my server can send messages to the client, and my client can also send messages to the server. So traditionally, before WebSockets, what we had was just AJAX. It's just HTTP requests that are happening via JavaScript. And those are always happening from a client to a server. So to make real-time stuff happen without WebSockets requires AJAX long polling, where you're basically setting an interval of every 100 milliseconds or 500 milliseconds or whatever, and to keep checking if something has changed. So WebSockets is a lot more efficient. Did you have a question or a comment?
Was there a WebICT presentation on WebSockets back in 2013?
Yeah, there was. Yeah, Ben Solon, he was actually one of the original founders and is not as involved anymore. But yeah, he did a talk on Socket IO specifically. I believe it's recorded, so it should be on devict.org/talks if you want to check that out. But I think Socket IO has come a long way since then, though, too. So, but again, so we have two-way communication here. So in our previous example, we were emitting an event from the client. In this case, we're going to emit our event from the server and let the client know that something has changed. So on change, we want to say socket.emit range. And another thing we can do with events is attach a piece of data to them. So if we want to send something along with what that event is, we can. In this case, we just want to send whatever the value of the range that it's given us is. So we're going to say range.inches. Again, that was coming from Johnny 5 here, showing us that we can just get inches from that object. So that'll give us the current reading in inches. And then just to show you guys the HTML again, pretty bare bones page. And I have an H1 here that shows range, and then I have a span in here that's empty with an ID of range, and then the little inches marker after that. Again, I'm pulling in Socket IO, creating my socket, creating a reference to that span where we're going to put the range reading, and then we say anytime my socket receives a range event, so again, we're emitting this from the server, so the client is going to listen for it. We want to take the value that's sent along with it, and then change the contents of that range span to whatever that value is. So again, pretty straightforward. And yeah, okay. So start this up again. And here's our range. So right now, so the thing is right here. So whatever it's hitting, the wall I'm assuming is about 50 inches away. So if I put my hand in front of it here, you can see it going down as I get closer and closer and closer. And so again, it gets a little squirrely as I get closer there. So yeah. But as you can see, it works pretty well. If I just point it out into the crowd, oh wow. I thought it stopped at about 100 inches, but it looks like it's going out a little bit further. I wonder who it's hitting right now. Looks like Dom. So yeah, again, pretty straightforward and pretty cool stuff. Does anybody have any questions so far? I really feel like I'm needing to fill up some time here. I should have just coded all the HTML by scratch too.
Yeah, I got questions.
Yeah.
So let's rewind and talk about the basics of the hardware here.
Okay.
One thing that you've got is called an Uno. It's related to an Arduino. You talked about hooking up a Raspberry Pi. Can you kind of just
Yeah,
do that for
absolutely.
a little bit?
So this is an Arduino. This is an Arduino Red board, which is SparkFun kind of put out their own version of an Arduino. Arduino is open source hardware, so people can take it and modify it. It's really, really similar to the Arduino Uno. It's almost identical. There's some minor differences. I know one of them is the particular USB connection that you're able to make with it. It uses mini USB, mini USB, I believe. I forget which is which, honestly. It's the one that's less common now. It's the one that, do what now? Mini? Okay. So, so yeah, I haven't worked with Johnny 5 on a Raspberry Pi specifically. I have in the sense that I've had Johnny 5 running on the Pi, which was then connected to the Arduino. But I haven't worked with the GPIO pins on a Raspberry Pi with Johnny 5.
So tell me the difference between an Arduino and a Raspberry Pi. I mean, you can run Johnny 5 on a Raspberry Pi, but you can't run it on the Arduino.
Yes, and somebody with more knowledge of electronics would be able to give you a better explanation. But the biggest thing is that a Raspberry Pi is a complete computer. It has everything that you need to actually run a full Linux installation on it. So that's why I'm able to actually run all of this Node stuff on a Raspberry Pi, because it's essentially the same as just any other Linux machine. An Arduino is a microcontroller, so it's optimized to work with these kind of just components that, peripherals. And I know that Dom would be able to give you a much better explanation. Probably a lot of people in here would be able to give you a better explanation. Okay, I know that that's the major difference. And I actually asked somebody one time why, a Raspberry Pi isn't as good of a fit for connecting components like this compared to an Arduino. And it's because the Arduino is basically optimized. Microcontrollers are optimized for working with these kind of components. So since there's a lot of other things going on a Raspberry Pi that involve running the entire operating system, their readings from these components and being able to communicate with them isn't quite as reliable and real time and as efficient. So, and again, that was an explanation that was given to me.
You can also strip down things and run real-time OS, like free Archbox is one really available.
On a
You can run bare on the metal on the Raspberry Pi.
Oh, nice. So.
And various other ARM chips. Raspberry Pi is ARM-based.
Gotcha. See, I'm learning things. But yeah, so does that answer your question mostly?
Yeah, it gives me a better picture. Thank you.
Okay, absolutely. So yeah, any other questions so far? I have one more example, so it's kind of fun. It gets a little crazy. Okay, so the next thing I'm going to show you is, actually I needed to keep that one open, is a sound detector. So this component I have hanging off my Arduino up here is a microphone. And I've got 5 pins. I have my power and my ground. And then I'm able to get an audio reading, which gives me an audio level, envelope, and gate. I don't know. So everything I've done with this so far has been using the envelope reading, which my understanding of envelope, again, I'm learning this as I go, is when you have an audio signal, the envelope is the range between the high and the low points on that frequency. So when you have a quieter sound, the envelope is lower because it's not vibrating quite as loud. When you have a louder sound, the envelope is higher because the range between the peaks and the lows on that frequency, on that wave, are larger. The gap between them is larger. So I've just been reading everything off of envelope, and that's given me the most reliable results so far. So that's the only pin I'll be working with on that one. But let's go ahead and get rid of our sonar. Get rid of that. Okay. So when I first started working with this, naturally, I went to the Johnny 5 GitHub repo. I scrolled through the list of components and tried to look for sound detector or microphone or sound or any audio, anything like that. And I didn't find anything. So at first I was like, well, that's a bummer. You know, I'm gonna have to figure out how to work with this a little bit lower level. But one thing they have on here is a sensor. Where's that? So sensor is, you can see they have some specific sensors here. So they've got slide potentiometers, force resist or sensitive resistors, photoresistors for detecting the amount of light. And I actually have a lot of these components that came with the inventor's kit. So again, if you guys want to stick around and play with these afterwards, you certainly can. But we also have this one just up at the top that is just a sensor. So this is just something that gives me a value that I can then do something with. So that was what I was looking for here. And when I create a sensor, I tell it the pin that that particular sensor is on, and then I tell it the frequency that I want to take a reading from that. So if I don't want it to be taking readings really quickly, I can tone that down a little bit, but it gives me the ability to control that. So, and then we have some properties here. So sensor.scaled is going to give me the current value of the sensor. I can also just get .value to get the current value. When you have a generic sensor, you're able to scale those values to a certain range of number if you want to work with it. So if I want to limit the range on this sensor to be between 0 and 10 as opposed to 0 and 300, because the number that or whatever I'm doing with the number would give me a better result, then I can just say sensor.scale, give it a low and a high range like we're seeing here, and then get the reading from that afterwards. Or we can just, oh yeah, and we see here, sensor.scale, we give it the low and the high, and then we have the data event, and we can get the value and raw. So really all we need to do here is get the value. So that's what we're gonna do here. So we're gonna call this audio since we know it's an audio sensor. And new 5.sensor. I'm gonna say pin. I have this on A1. And we'll give it a frequency of, let's go with every 25 milliseconds. And then down here, I'm gonna say audio.onData. So I'm not gonna scale it in this case. I could, but I'm just gonna work with the raw value. So when I get data, I want to say socket.emit. The audio. Yeah, what I called the event here. Sound. So emit sound, and then attach audio.value. Again, this should be looking very familiar by now. They're really great about giving a common interface for all the different Johnny 5 components. You have a data event whenever you get a new reading on what the value from that sensor is, and then you can get the value of that from sensor.value. It's pretty consistent, which is nice. Let's restart this. Listening on 3005, jump over here. And here's our sound value. Hang on. Okay, so I'm doing a couple things in this web page here. I have so at first, I was showing just the volume. I was just showing the reading of the value the same way I was showing the range value. Since it's just a raw value, it's not mapped to any particular sound measuring unit, so I just called it sound units. But since I showed pretty much exactly that thing for the rangefinder, I want to do something a little bit more fun. So what I did is I made a word, I put a word in here in a paragraph, gave it the idea of noise, gave it a little bit of CSS up here, and where is, we don't need that. So I'm doing a couple things here. I set the font size of that word noise to whatever the value that I'm reading from the microphone is. So as it gets louder, we'll see the word grow in size. And then I also changed the background color. And I messed with this a little bit. I wanted it to go from green to red, but I didn't quite get it working perfectly. But it does change color. So the background color of the page will also change based on that value. I just set it to an RGB, setting the red value to value, and I multiplied it a little bit to get that range to show the change a little more drastically. And then set the style of the page background color to that RGB value. So let's see it. So there we go. And it's actually, let me scale down a little bit here. So does anybody want to yell? Louder! So yeah, so that was a little fun thing to do. And this was, I did a project recently that was a lot like this. And I guess I can show that. Maybe. But I used the sound sensor and the ultrasonic rangefinder and this canvas, or actually an SVG library called D3 to just generate some animation stuff on a web page. And it would respond to sound here. So this was a little project I had set up at the Make ICT open house. Circles. Node server connected. I don't know if I'm on the same, should be. Whoops. No, I think I got my sensors backwards. Give me just a second here. So audio should be on A1 and range should be on A0. There we go. Start that again. It's over. So what this does is if it gets an audio reading over a certain threshold, then it'll generate a circle on the page. The duration that the circle fades out over is longer, and the circle maximum size that it grows to before it's completely faded out is bigger if the value is bigger. So, and then what the rangefinder, I realize that's really difficult to see up there. What the rangefinder is doing is controlling the lightness of the circles. So you can see they're very dark right now because there's nothing very close to it. If we generate some circles and then I get my hand a little bit closer to the rangefinder here, you can see them, brighter colors. So this was a lot of fun to do. Yeah, it was really fun. This was the kind of projects I wanted to do, just like interactive art pieces, because I'm not actually an artist, but this is how I can pretend that I'm an artist. Plus, it's fun because people get to come by and play with it, and that's awesome to me. And this is such a simple thing. I felt like a fraud putting this on display in public at all because it was just so simple and easy to get set up and working. But nobody cares about that. If it's something fun to look at and mess around with, then they enjoy it. So I had a lot of fun, watching people come by and play with it and watch it react, and especially all the little kids that came by and yelled at the screen. So that was great. So yeah. But that's everything I had. Again, I intended to have a couple other demos. I didn't quite get the things working that I intended on. One thing I wanted to show was how to integrate Twilio. So if you're not familiar with Twilio, it's a service that allows you to send and receive text messages or phone calls through a web API. So you can have a Twilio number and you have your API key and all that stuff, and then you're able to send text messages from a web application or phone calls, or you can set it up to receive phone calls and text messages as well. So using like the proximity sensor, it would be really, really easy to set up something that would alert you if something was too close to something. So if you know it's 2 a.m. And there should be nobody walking up to your front door at that time, you can have a rangefinder sitting on the outside of your house that can detect if something is within a certain proximity and call you or send you a text message to alert you. And that would take a very small amount of code. So I mean, that in itself is pretty awesome. But yeah, I had a trial account for Twilio, messages weren't going through, and for those of you who showed up close to the beginning, you probably saw me trying to get that working and I didn't, but that's okay. So yeah, so that's all the demos I had. Again, the main point that I wanted to demonstrate here is that Johnny 5 and Node and JavaScript in general make it really, really, really easy to get into hardware hacking. Especially for somebody like me who still knows very little about electronics. And I was able to accomplish a lot of cool little projects and have a blast in the process. So hopefully I've done that, but that's all I have for you. That was fun. Do I have any questions? Yes.
Can I just say a couple things?
Yeah.
If anybody's interested, Make ICT is hosting a basic electricity workshop on May 9th at 1 p.m. It's a free workshop, so you have to register though. You have to RSVP to reserve a seat for that, but it's totally free. You can come learn about electricity. Also, if you're interested in doing a hands-on workshop with your Arduino, we can put one together. Come see me, and I will get down your email address, and I will email you when we schedule it.
And those are both things that I should probably do myself. So, anything else? Yes?
Is there any relationship to the, I'm not very familiar with it at all, I just run across it, the open source robotics language? I mean, it's called. What that is?
I don't. I'm not sure. I don't think so, honestly. This is kind of its own thing. Node was a project that was launched just to put a runtime environment for JavaScript on the server side, because traditionally it's been a client-side web language. And then ever since Node was created, a lot of things have come out of that. It's really big in web development. It's really big in the Internet of Things and this kind of stuff. So, yeah. Yes?
What's the new Johnny 5 site that just launched?
I think it's johnny5.io. Yeah, johnny-5.io. Yeah. Any other questions? Cool. Well, again, you guys don't have to leave. You can stick around and play with this stuff for a little bit. And yeah, thank you all for coming.